Hey guys, this is just going to be a quick video on vector operations. Okay, so the first thing that I want to do is I want to look at vectors. Let's say look at vector A right here. If I wanted to figure out what 2A was, basically all I do is take this vector and add another vector on top. So take A and I add A on top. This is what we would call 2A. We have scaled this vector. Whenever, I don't know if you all really like to watch Shark Tank. All right. Something that Shark Tank always is talking about is getting things to scale. What in the world does that mean? That means if I have a product, let's say I have, I don't know, I'm selling shampoo bottles, okay? Selling shampoo. And my customer base is 1,000 people, okay? And I've got the best shampoo in the world, and I go on Shark Tank and I say, you know what? I'm a great inventor, but I'm not really a businessman. I don't know how to bring this to scale. And what Shark Tank, hopefully the guys in Shark Tank are going to do, maybe Kevin O'Leary is going to come to me and say, yeah, I want to scale this big. I want to make sure, I want to bring it to scale or whatever. What does that mean? That means that as soon as I go on Shark Tank and I get one of the sharks to help me, my shampoo business now might have 1 million customers. I have exponentially increased, or I have multiplied, I've actually multiplied my business by 1,000. My business has scaled. Okay, it doesn't look like a D, but you get the idea. I have scaled my business. All right. So the same thing is true with a vector. To scale a vector, it just means that you have, say I have this vector right here, and I want to scale it by a factor of 3. Well, that just means it's going to become 3 times as big. Does that make sense? Same vector, same direction, but the magnitude increases. The direction didn't change, but the magnitude became 3 times as big as it was when we first started. Okay? So that's scaling a vector. The second thing we can do with vectors is add them together. So for example, let's say that I have this vector right here. I'm going to call this vector A, again, just for continuity's sake. And I'm going to call this vector B. All right, so I've got vector A and I've got vector B. And I want to know what would happen if I put A and B together. In other words, let's think about it this way. Let's say that, once again, I've got me, I've got my friend Billy. This is me, my friend Billy, and my friend John. I've got me, I've got Billy, I've got John. The vector to get from my house to Billy's house is A. The vector to get from Billy's house to John's house is vector B. My question to you is, what is A plus B? Well, let's think about it. Where did I start? My house. Where did I end? Billy's house. A plus B must be this vector right here. Make sense? If you start here and I went to Billy's house, and then I take Billy's house and I went to then John's house, the quickest way actually to get there is to go from my house to John's house. That's why the vector A plus B starts at A and ends at where B ends. Does that make sense? You always start with the first one and then you move on to the next one. Okay? Notice the other way around would not be correct. Because remember, I would have to walk along the arrows of my vector because vectors have magnitude. Okay? And that's all there is to adding vectors together. So let's say that you're given this vector A and this vector B, and I ask you to find 2a minus b. 2a minus b. Now, how would you do that? The first thing you're going to do is we have scaled this vector a. So basically you're going to have, that's your 2a right there. Then notice b goes in this direction, so therefore negative b must be this way. So that's what we'll do. This is a, this is a. So now what we do is we put it all together. We start with our initial point, and we end at this terminal point. And this right here is 2a minus b. That's it.